Good morning, everyone. My name is Nick Bryan. I work with Long Building Technologies out of our Fort Collins office. Today, I'll be presenting with Cambridge. On the call with me today is Justin Screeman, who's our local RSM, and then Chris Leach, who's one of Cambridge's application engineers. Typically, when people think of Cambridge, they think of heating and ventilation units. Recently, they've expanded their product line, which includes evaporative cooling in a rooftop or unit. And with that, I'll hand it over to Justin to talk about that.
Thanks, Nick. All right, so I am Justin Screeman. I'm a mechanical engineer up here out of Boise, Idaho. I work for Cambridge Air Solutions. We are headquartered right outside of St. Louis, Missouri. We have been building different types of heating and cooling equipment for the last 60 years. 2023 is actually our 60-year anniversary. So on the call with me, I have Chris Leach, who is our applications engineer out of Nashville. And what we're going to talk about today is evaporative cooling technologies, and we're going to quickly touch on the other technologies that Cambridge offers that you may know us by. So the majority of our equipment that we have made for the last 60 years is comprised of heaters. S-series is what we call it. It's a specific section of the industry called HTHV, high temperature heating and ventilation. And we have historically served mostly the warehouse markets, also the manufacturing, industrial, and different types of markets such as that. We can get into high-rise type applications. We can get into gymnasiums, different types of applications. Recently, we started to expand our product line about 5 years ago. 5 years ago, we were nothing but heaters and makeup air units. And then we started to recognize the need for cooling in some of these facilities as our weather changes, as the expectations of employees change. One of the things that changed is they want to have a maximum temperature within their facilities. So to that end, we started investing in evaporative technology and brought a product to market about 5 years ago. That product is the E and the ESC. We traditionally make a makeup air unit called the M series, and we can incorporate the direct cooling technology into that M series. So for the most part, we're just going to talk about the E, the ESC, and then one other piece of equipment that we haven't launched yet in this presentation. So about 5 years ago, we started looking at cooling our own facility. We realized that we needed to create a better environment for our workers because that's what we do for all of our customers. And it was starting to warm up and the expectations were changing a little bit. So typically, what most people in manufacturing and warehouse environments have is on the low end of the complexity side. They're bringing in their ventilation with fans, exhausting their stale air with fans, mixing their air in their space with fans, a lot of times the HVLS type big ass fans. Those are great, but realistically, at the end of the day, all they're doing is ventilating and moving hot air around when you're in a hot environment. So we have to start looking at the other end of this chart, the more expensive, more complex, if we actually want to lower the temperature in that building. So the first thing that we looked at as a manufacturer is a mechanical cooling system, specifically a DX, but this could be hot water, chilled water, other sorts of technologies. We did an analysis on our 100,000 square foot building in St. Louis, and we were looking at spending roughly $500,000 per year in energy usage. So we started looking at other options that our customers look at, because when we are in a manufacturing environment, we are exhausting and throwing away most of the air that we've conditioned, if not all of the air we've conditioned, every single time we make a pass on that piece of equipment. So when you start looking at direct and indirect evaporative cooling equipment, it's one step below mechanical cooling systems in price. It's roughly the same first cost, but where the real savings kicks in is on the energy usage. We were able to use less than 1/5 the energy using evaporative cooling technology than a DX cooling system. And that doesn't necessarily mean, and especially in our case, that evaporative cooling technology is going to add a bunch of complexity to the building. In fact, we were able to integrate our heaters and our cooler into one piece of equipment, along with some filtration and being able to vary the air. Now, when we bring that air in and we've cooled the facility, remember, we're going to exhaust it all. And so another piece of equipment that we're going to be coming out with, we'll be launching this in February 2024, and I'll just touch on it briefly at the end, is an air turnover unit. So we can actually use our evaporative cooler as a first stage of cooling, a temperature depression, if you will. We cannot specify a set point in a building based off evaporative cooling technology because it's totally dependent on what the outside air conditions are doing. So what we can use an evaporative cooler for is, let's say, 90% of the load. Then that last 10% of the load, or the trim load, if you will, we can trim with a mechanical cooling system. Doesn't matter what it is. It could be chilled water, it could be VRF, it could be an air turnover unit. If you're not familiar with an air turnover unit, it's basically a giant fan coil that sits in a manufacturing environment and can cool up to 150 tons with a typical DX split system. Running that is a lot more cost effective when you're already pre-tempering the air in your space. So what is evaporative cooling? For those of us not familiar, it is basically evaporating water, think like a mister on a hot day, in hot, dry air. The hotter and the drier the air, the more cooling effect you get out of evaporating that liquid. For that liquid, we are typically using water. So looking at our E-Series, this is kind of our entry-level evaporative cooler. It is the lowest complexity, lowest cost of ownership, lowest first cost piece of evaporative cooling technology that we make. We can do up to 80,000 CFM and up to 200 tons. We can get into some customization. We can do stainless steel sections. We can add VFDs and vary the amount of air. But at the end of the day, it's a pretty down and dirty basic piece of equipment. What this is good for is replacing a large quantity of what we typically refer to as swamp coolers. So I was actually just on a building where we had 20 swamp coolers. They were difficult to maintain, difficult to modulate. There really is no control system. And so this person was looking at consolidating all 20 of those into one evaporative cooler. With one evaporative cooler, you get one piece of equipment, one set of controls, one set of maintenance requirements. So why would we use a direct evaporative cooler? Well, we would typically use one in a building where we do not care about how much humidity is in the space. The drawback of a direct evaporative cooling piece of equipment is it is mixing air and water. It's very similar to a cooling tower. We are drawing water down a piece of fill and we are blowing air across it. So the air and the water are in direct contact with each other. We saturate that fill and we blow air across it. And so all of the humidity, all of that latent energy that we've added to the air gets carried into the building. And so for that reason, we have to be cautious on how we control that. And the best method of control is a humidistat in the space. You set it at whatever you want, 50%. When the relative air gets higher than 50%, relative humidity gets higher than 50%, it will shut off the water. We can continue to ventilate the building, but we're going to stop adding that temperature depression or that cooling effect, and we are going to just ventilate. As I said, this is the lowest complexity. So there aren't a whole lot of options available to us in this piece of equipment. It's pretty basic stuff up to 80,000 CFM. When we want to get into more of the custom options, we have what we call the ESC, or the evaporative semi-custom cooler. This also can have direct cooling, but it also adds the capability to add an indirect cooling section. A second stage is what we call it. So this is a two-stage evaporator. We can also add additional components. We could add DX coils, hot water, chilled water, anything that you would typically think about adding to a custom air handling unit. We can typically add to this. It's a post and frame construction as opposed to a unitary construction like a typical rooftop unit or other piece of equipment. It's very customizable, and we'll talk a little bit about what that second stage brings to the table. So what two-stage evaporative cooling is that first stage is going to be different. The second stage is going to be exactly the same. That's going to be that direct evaporative cooling. We're able to get a bunch of capacity out of that, but we have to modulate it with a humidistat in the space. Instead, what we can do is we can use a indirect section as opposed to the direct section, or in addition to the direct section. What the indirect section does is it is a plate and frame heat exchanger, and probably the best diagram is up here in the upper left. It's a plate and frame heat exchanger made of polymer sheets. And so the polymer sheets are what transfer the heat. What it does not do is it does not transfer the latent energy. So we have two different streams of water going through there. One is for evaporation purposes, what we call scavenger air, that we discharge out the top and throw away. The other stream coming through, and you can see these arrows on the side here, that is fresh air from outside. We're going to pass it through a polymer channel in here, a plastic channel, so it never comes into contact with the water. When we do that, we can cool the air, not as much as we can with two stages, but we can cool the air without adding humidity to the space. So we can get into much more custom offerings with this type of equipment. One of the things we can do is what we call energy recovery, and that is where we don't just do a single pass on the ESC series, but we actually have a return air system where we can loop it back through, and therefore we can continue to cool that air at a much lower operating cost. So let's look at what type of performance we can get out of these and what the operating costs look like. So in the Rocky Mountain region, we are region 5 here, and the regions are broken down even more granular. I'll draw your attention to line 5B here for Denver, Colorado, and coming over here to the leaving air temperature from the second stage of cooling, we can get down to 51 degrees leaving air temperature. And so that is very similar in performance to what you can get out of a piece of DX equipment. And we can get up to, as you can see over here, 40 plus tons of cooling out of 10,000 CFM. So what does that equate to on a cost basis? Well, looking at Phoenix, which is probably the closest that we have to our climate here, if we were going to operate a 25-ton cooler, we can operate it. And again, these costs are roughly 3 or 4 years ago. So realistically, this cost has not continued to go up extravagantly. This one has, our electric cost. And so we're going to be operating this piece of equipment for roughly 10–15% of the cost of operating the equivalent DX. Now, that doesn't mean that we don't run the DX. One of the best ways to use these evaporative coolers is as a pre-cooler. And we pre-cool the air. We can even recirculate and pre-cool the air, giving you a little bit of heat recovery. And then we can trim it with a piece of DX equipment. So that is what we're doing in our space with this air turnover unit. It costs very little to operate that air turnover unit because we're only getting a few tons of cooling out of it versus what it's capable of, 150 tons. So we are able to see operation costs down in the 65 to 80% of the energy usage of a traditional DX equipment. So one thing I want you to keep in mind is when we're seeing these unique situations, such as where you get thunderstorms in Denver and you get a very quick burst, we are able to quickly recover that and switch over to this second stage of cooling as opposed to the first one that is adding more humidity to the space. So with that, I will hand it over to Nick. Thank you very much.
Thanks for joining us again for another coffee break. Next week, Mike Jacobs will be presenting, and we'll hope to catch you then. Thanks, everyone.